Welcome to ET Auto and to this very special episode of Technology Talks. I say it's a very special episode because in this episode, we have not one, not two, but 6 industry leaders who are going to discuss on the theme of driving the green revolution, meeting the sustainability challenges, and also innovations in the automotive industry. So it's my pleasure and honor to introduce the guests of this episode of Technology Talks, starting from my extreme left, Raghuraman Ayaswamy, Senior VP and Global Head, Internet of Things and Digital Engineering Unit at TCS. Then we have Debashish Neogi, Managing Director of Renault Nissan Tech Center in Chennai. And to my right, I have Guru Malikarjun, who is a Senior VP and Senior VP of Mobility Solutions at BGSW, that's Bosch Global Software Technology. And then we have Lata Chembrakalam, who is the head of Continental's Global Tech Center in Bengaluru. And then we have Mr. Kishore Patil, MD and CEO of KPIT Technologies, and Kishore also wears the hat of the chairperson of the ER&D Council of NASSCOM. And then we have Siva Polimetla of NASSCOM. Siva, everyone, welcome to the show, and thanks for sparing your time to have this, which I'm sure will be a very, very enriching and informative discussion on the theme of driving green revolution, navigating or rather meeting sustainability challenges and innovations in the automotive industry. To start off, let's look at the big picture. We are here in Bengaluru, a hub for major ER&D centers, and it is also home to a lot of global tech centers, both from OEs and tier ones. So if I were to ask you, Siva, since you know all the details of the ER&D industry and the trends, 1.4 to 1.8 trillion was the overall ER&D spend last year, projected to touch or cross 3 trillion by the end of this decade. Yeah. Automotive, and it is one of the top 3 spenders. Yes. So what is the trend like, if you can throw a light on, and what are the key drivers for that?
Definitely. So broadly, if you see that the overall India ER&D exports stands at $44 billion. And it is also a fastest growing segment in overall India technology sector. Last year, the ER&D contributed 48% of the incremental growth of tech sector. So coming to the automotive, which is also a fast growing sector in ER&D, so it contributes closely 10 to 12% of the $44 billion ER&D exports. And if you really look up today, India is home for about 65 global capability centers, as well as if you see the global top 50 engineering service providers, 47 of them either headquartered in India or having the centers in India. So if you really see the trend spots, the leaders will talk more. So definitely if you see that we started the journey in India more on the connected autonomous electrification. Now the next wave is on the software-defined vehicle. Everyone is working. But looking at what is the unique advantage of India for ER&D in automotive, one, definitely all these companies have built over many years a rich domain experience. I think that's more foundation. The second is the rich talent, right? So we have the largest English-speaking STEM graduates. The third is the reskillability of the people. Right, so this is definitely an advantage for all the companies to leverage India for innovating for the world.
Indeed, innovating not only for India, but for the world. And then we have an example of an Indian company which is really making its mark across the automotive industry globally. And KPIT is the company I'm talking about. And Kishore, you cater more to global OEMs than to Indian OEMs, and that has been your strategy. And ever since you took the very calculated risk of pivoting the company only to be focused only on automotive software. Since we are talking about sustainability also, one drives through Bangalore traffic, you really feel that there needs to be it needs to be more sustainable. Well, you can't do anything about the roads, but when it comes to sustainable transportation, what are the trends that you observe now, and what are the key focus areas of global OEs that are your partners?
So I think now the game has accelerated. Earlier, people were only focusing on SDV, what they can achieve out of SDV, and I will talk about it, when people were really focused on Tesla competition. So they were looking at SDV because you can reduce the number of controllers in the car, have the software, reduce the overall software cost over the period, have basically green coding, right, increase the efficiency, and have a better design, centralized architecture to do that. That was one part. The second, of course, traditionally has been the electrification part and what things have been happening. I think the third part, which I think people had deprioritized in the past, is my view, but opened our eyes through China competition, was reduction of the materials, reduction of the weight and the cost. And fundamentally, any reduction in the cost and the weight leads to sustainable this, because the material is reduced and this. So I think, in my view, these are three things which are happening at a different level. Naturally, within that, there are many things which are happening, like which are the different, now only not only electrification, but also hybrid. Then there are, of course, fuel cell-based commercial vehicle, different types of batteries. You told me about what we do outside India, but as you are aware probably, but in India, we have developed a sodium-ion battery for Indian condition, which will be better, well self-sustainable. So there are many solutions are being developed by different people, I'm sure, with my colleagues. So this is what is happening. But the most important part in this is, if I may say, once the product is designed, there is less than 10% changes you can make.
Right.
So what you can do at the time when you are architecting the overall vehicle, and this will make the best difference. I think that is the fundamental thinking.
And since you touched upon design, it reminds me, recently I heard a global industry expert saying that 80% of a product's environmental impact is determined at its design stage.
Absolutely.
Right. So talking about that, Raghu, I mean, tell us from a manufacturing perspective, from design and engineering perspective, what are the new approaches, what are the new technology trends that are emerging and likely to emerge in the near future, and India's opportunity to really kind of lap it up and also have a more sustainable journey?
I think today the design is not following the traditional approaches. When I say that, it's not just about electric vehicle or any other, even IC engine design. So the design is about how can you design for sustainability. So the design starts with the selection of materials and also the complete life cycle of that material from the usage. We call that as end-of-life assessment. How can you really make these products which could be ideally 100% recyclable, if not 95%, 98% recyclable, and then have the systems and ability to track it from the point of origin, from the design stage to manufacturing till it is getting into end of life stage. So the sustainability aspects of that is built into the design process. And today I think many of the tools that we use generally for simulation also build capabilities to make those assessments. So whether it is a choice of plastics, whether it is choice of steel, whether it is choice of any other material, we can go through the complete life cycle assessment of the sustainability quotient for that. These are all methods and the tools that are getting developed, and databases are required to track the history and lifetime of those parts. And all these procedures also, there are systems that are getting developed, and all Indian companies are quite involved in that.
And again, like some of your industry peers, TCS has a global presence in terms of its clientele and the services that you offer, engineering services. Can you share some anecdotes in terms of how much of an enhancement have you been able to help companies achieve in terms of, let's say, in their sustainability drive and maybe reducing the various, let's say, wastage or basically overall improving the green quotient?
Yes. No, I think Kishore pointed out, it's about, you can improve the sustainability quotient on multiple levels, like reducing the weight, reducing the amount of drag that the vehicle has to go through, because that directly correlates to fuel consumption. And of course now sustainable technologies, which is in the case of EV or fuel cells or hybrid itself, it could be sustainable technologies. And in the manufacturing also, how can you really make the plant completely sustainable from the manufacturing? Don't consume a lot of energy, or at least optimize the consumption of energy part of it. So in all these aspects, today we work. I think the one instance I would definitely quote an anecdote. We worked with a Japanese OEM, and one of the things we were really working on, the design simulation aspect, is related to how can we enhance the range of their electric vehicles. And the straightforward formula for that is look at better battery storage and the capacity so that we can increase the range. But there are other ways. Is the choice of materials for all the reducing the weight. The other is the aerodynamic design. When it was actually, we simulate that through some of the Gen AI simulations, could yield considerable improvement on the mileage actually, because that's the way it has impact directly on the outcome of the range part of it. So those, by building that simulation capability and putting that kind of models, you can actually improve the sustainable designs. It's not just going for EV solutions, but you can actually put this in the engineering process itself.
To what degree can it be kind of enhanced?
It could actually, in this case, we could achieve close to around 10% improvement in the range by making minor aerodynamic changes on the contours of the vehicle trim.
Now, at this level, let's bring in the OEM's perspective, because Debashish Neogi heads the Global Tech Center for Renault and Nissan, both, as we all know, are global players. And his team is working on projects which will see SOP or will roll out in the market then in let's say 3 years, 4 years down the line, and almost all of them could qualify as SDV programs. So Debashish, tell us, how different will those creatures be, and in terms of their sustainable quotient, this whole SDV, kind of architecture. If you can share some anecdotes, also the kind of projects that you're doing for, be it for Europe or Japan, and some of it for India as well, right?
So, very good question. So, my colleagues touched upon design for sustainability. Now, a specific question on SDV, right? So, as Kishore mentioned, SDV is bringing a big change in itself because the number of ECUs in the car get reduced. It's a centralized architecture. So, and also number of ECUs getting reduced means the number of copper and wiring harness used in the car is also reduced. So, overall, by design, it is very sustainable design. Now, I'll bring a very interesting aspect of SDV is that your car is getting continuously refreshed, right? And it is estimated that the residual life of the car will increase by another 2-3 years. It's a huge impact. So if the customers are able to keep the car for longer period, it helps sustainability, because one key lever of sustainability is to extend the life of the product, okay? So I think SDV is a game changer because you can refresh the car never goes old, and you are able to bring exciting features very similar to what are the features in a car which is rolled out from the production line today. The cars in the field will enjoy those features. So I think SDV plays a role in sustainability. And I would say that if you want to say that in the latest car, how OEMs are hell-bent on sustainability, all the major governments have said carbon neutral by 2050, India will go carbon neutral by 2070, China by 2060. The OEMs are also committing themselves. For example, Renault commits carbon neutral by 2050 for the rest of the world and 2040 for Europe. And Nissan is also committed to 2050. So that means all the systems and processes right from cradle to grave. That means, as Raghu pointed out in the basic car design, how to use recyclable material, right? How to lightweight it, how to design for repairability, because if you are repairing the car and you have to completely replace a big assembly, whereas only a small part have to be replaced, is not good for the environment. So how you design for repairability. Design for manufacturability is important, because if you can make a modular approach, that means you reduce the number of parts getting into the assembly line. So we are tracking how many less parts the assembly line has to manufacture or assemble. So like in e-powertrain, there is a concept of 7-in-1. That means the charger, the rectifier, the battery management system is all in one box. So that means the operator on the assembly line has to just fix one big assembly rather than putting 5 different components. So the CO2 level of CO2 emitted by the plant to manufacture an EV car will come down dramatically. So I think right from cradle to grave, every aspect of car making, sustainability is now getting embedded to reach the carbon neutral targets, which are very, very important. And SDVs, of course, is a big part of it.
Right. Okay. And since Raghu, you have to leave.
Yeah, we are now in the midst of the NASSCOM Design and
Yes.
Engineering Summit. So I have a panel to join, and great to be part of this discussion, and I really look forward to having continued conversation on these interesting topics.
Thank you once again for your participation. Wishing you and your team all the very best.
Thank you.
Okay, let me come to you now, Guru, talking about mobility solutions, future of mobility. Autonomous driving. The first letter of the acronym ACES seems to be now falling behind the rest. The goalpost seems to be moving. What is the scenario that you see currently, the realistic one, where perhaps, no? Let's not talk about L5, we can, no? There's some, in one of our earlier discussions on the show, one CTO of a engineering service provider said that, I'll stick my neck out and say, L5 is not going to happen in my lifetime. Well, that's the debatable issue, but different perspectives. But tell us, how do you see this autonomous driving megatrend progressing?
Yeah, so exactly in 2020, when we all started talking about this autonomous driving, I think everybody was joining the bandwagon, saying it's going to be a big bang. So 2025, everybody would be driving a completely autonomous car, which is L4. But I think over the last 4 to 5 years, we've all come to the terms. It's not as we all assumed in the beginning. The S-curve that was planted in, let's say in 2020, where autonomous is coming into the matured state by 25, 26, is definitely getting shifted by at least by 10 years. The second is, we still believe there's going to be 2 S-curves that's going to stay together, definitely for some more time. We call it as green curve and a blue curve. Blue curve is where we are still talking about the current core that we are working with, which is up to, let's say, L2 or whatever. But the green curve could possibly get moved. So now it's very important for us as players to look at how do we balance these two. And so what we're trying to do is, as in a technology world, we are trying to understand what is really coming up. Even in both the world, common things are the velocity is changing. The velocity of the change, the velocity of demand is completely changing. It is driven, of course, starting with China's speed, but even Indian OEMs are picking up the similar demand. And now European OEMs are also following that. Yeah? So that is the velocity is coming in. Second, another thing which is a big thing happening is the regionalization. So it is no more that I develop in one and then I deliver to the rest of the world. I think that is also very, changing a lot. Now this is common in both, whether it is, I'm talking about the blue or the green curve. So one thing we are trying to do as we move forward is to get on with more of a building block approach. So we don't go anymore that I develop the entire system, so that I deliver, and then I'm good to make only the variants. Because the regional and the customer specific demands are changing. So we are now getting into more of a building block approach, which means I can wire them differently so that I can get the velocity, so that I'm quicker. I'm also able to create the variants in much more faster. So that's a big shift which is happening. Now whether it is L2, L3, L2 plus, I think that is something we need to take it on a region by region. So there is not going to be one solution for everybody. You can't imagine L2, even L2, L2 plus in Indian conditions happening very soon. We actually had an experience of localizing one of the global OEMs L2 feature into the local conditions, and it was very, very, I would say, tough time to understand. We need to take a car, go across the country to understand what is happening. I mean, just an example, they were identifying a four-legged cow which is not expected on the road as two people standing there. So we have to really completely configure and calibrate the entire ADAS functionality. So I think it's still a long way to go. Infrastructure, I don't think it is ready for it. I think even the much developed nation, which is a little bit ahead, is also kind of not caught up with that yet. So infrastructure will bring in a big challenge. And SDV is a lot around the eco-space. ADAS is around the eco-space. And maybe the smartphone industry has learned it much faster than us. I think they have learned about standardization, abstraction much faster. We are now learning how to separate hardware and software. I think that itself is a journey that we have taken. So it's a journey I think we need to go forward and look at how this infrastructure develops, how we are able to move towards take away certain things out of smartphone, and able to operate an ecospace. I think ecosystem space, I mean. So, and I think ADAS is also about partnerships. It is, I don't think one could deliver everything.
Correct.
So how do we bring the ecosystem together where partners are coming together? We take the best of everything and then we're able to deliver it in quick time. So I think it's a journey, it's a learning journey that we're taking.
You mentioned about the cow example. In fact, I recall one of my earlier discussions with another gentleman from the industry. He was saying about, unique to India, the auto rickshaw. When it crosses the road, the LiDAR or it may pass through the middle part of the auto and read it to be something else.
There's another challenge we had. Typically, ADAS looks at 2 meters. That's the standard global calibrated value. 2 meters, we expect there is no vehicle. So we don't expect to bumper traffic. Now, within 2 meters, there is a vehicle crosses, two-wheelers. Our system could not recognize there's a two-wheeler in between. So it has to be, again, configured to the local conditions. So I think some journey to go.
Right, some journey to go. But and also, you mentioned about the building block approach. Lata, coming to you, talking about the building block approach, I believe Continental is close to or has already developed autonomous park assist system, which will be rolled out in India sometime next year. Could you throw some, take us briefly about how was the journey of the development journey? What are the challenges you faced, and how did you address them? And would this be something that would be now rolled out in India and adopted across the markets where Continental supplies to?
Yeah. So if you look at a park assist system, it is, I'm not telling it's very easy, but it's relatively easy to implement because the boundary conditions are very, very limited. Yeah. So even that in a system, in a country like India where we don't have marked parkings and there are no standard dimension, standardization of anything available, that itself is a challenge. But the thing is that, it's a proving ground for the technology, and there is a lot of consumers who really want it at this point of time. So I think L2 Plus getting rolled out in India will not be a challenge, and I'm sure that many OEMs would adopt it in the future, and I think many OEMs and tier ones are together working on this technology. But the challenge comes when you look beyond that, like Guru mentioned about it. Yeah, when you have an ecosystem where there is so much of unpredictability and there is so many non-recognizable objects which are there, that actually becomes a challenge. But I would say in a very closed environment, a limited parameter system, ADAS will work, because I think the algos are pretty good, and it has reached a maturity where it can there. The challenges would come again with respect to the infrastructure that we have, the connectivity that we have in the country. Again, very different driving conditions, like what Guru mentioned about, something and a scooter crossing the road when in a 5-meter distance. Again, recalibration of the sensors itself, because recalibration of every sensor is really required, and when you have these potholes and others in the road, so sometimes the position of some of these, the sensors also changes. So how do we have mechanisms to even auto-calibrate these sensors? So there are a lot of other challenges which are there where the system is not closed. So according to me, in a closer environment, the technology is proven and it can work well. It will be rolled out, yeah.
Just another additional point where I think is how much it gets monetized, right? How much is ready to pay for it. So we try to do this autonomous valet parking. We try to do it in Singapore. It comes at a very high cost. So it's nice to have. Will I pay for it? I think that's a big question.
I want to add one more perspective to it. See, when you look at the autonomous drivings, the fundamental idea is not only comfort. The whole idea was to have a vision zero, which is zero fatality, zero injuries, zero accidents. That was the whole concept that the industry was working on. But I think now we are trying to talk it like it's a comfort feature, right? To get into that situation where we have no fatalities, no accidents, and in a country where there are so many accidents, like India, I think it takes us a really long way to reach that kind of an objective. Yeah.
Therefore, I think beyond the technology, the awareness has to be driven so that the end consumer has the appetite to pay the premium.
Awareness, affordability.
Affordability is key.
Yep.
Yeah.
Because we have still not mastered the value chain. Even in Europe, when you talk to the CTOs, they have not gone beyond L2 plus for generalist manufacturers. Okay, we can have a Toyota bringing up with a L3 or a Mercedes with
Or a
a
Waymo.
L4, right? But mostly it is L2, L2 plus, because even affordability is not there. And more so in India, the entire value chain, right from sensors to ECUs, etc., we are all importing it. So we have to be self-reliant on localizing those technologies and to be affordable. So that's also the big challenge in terms of application in India.
I have a few points. So first thing is, it is about the business model. I think for PASCAR, the business model is very difficult for L4, L5. It's very difficult. Affordability and this. Unless there is, the other part is the technology is there, but I guess there are a lot of things around technology are not there. I mean, I'm also part of mobility group worldwide of World Economic Forum. And we're working out how adaptation of this technology can happen worldwide. So the other part is how the drive, any person who drives, for example, I have a L2 plus car, but how do I drive that car is also very important, even though you are aware. So how much you can do that? So there are a lot of things which you need to do in order to really have that. But one thing I might tell you is the business case works for Robotaxi. Robotaxi. And it will be the first one which can happen in certain areas.
Which is why I guess GM is not still giving up on Cruise or Waymo.
Yeah, I mean, they have to reduce the cost. But if you look at, when there are trials which are happening, and to her point, basically, some airports have already automated vehicles. Hong Kong is the first airport which has that kind of a traffic. That kind of a thing now I see even within the factories and etc. So some vehicle, that kind of a thing will happen.
In a closed environment.
Closed environment will happen.
Yeah.
But the Robotaxi, what China is trying, I'm just if I had to put it a little bit. So they have two ways. One is they will have a dedicated superhighway from where this will go, very fast. And I have seen the prototype, you won't believe, in 1994 in a university in US. So it is like you form a train and you fast move. That's the one prototype. And
Where was this?
Berkeley University.
Berkeley.
So the second was, the second part is as the data and this thing come, in a limited environment, in a little bit environment, you start introducing, and then slowly it picks up. So these are the possibilities. I'm not saying.
Even in fleet management, it
I
is
was
possible
about to say
because
that in the CV
Yeah.
fleet,
Yeah,
Yeah,
and
absolutely.
talking about CVs, in fact, one of the major OEs has tied up with a startup in the West, mainly for autonomous driving in port terminals,
Yeah.
for example, where it is a controlled environment and it's clear demarcated.
Continental has tied up with a company called Aurora,
Aurora,
in US,
yes.
and this is basically for L4 trucking application. And,
2028 is the target year, I
yes,
believe.
that's right.
Okay,
Yeah.
okay, that's great. But no, we're talking about technology and the technology developments. Siva, tell us top 2 or 3 challenges that technology companies are facing, ER&D providers in India especially.
Yeah, so one is, technology changing in very rapid phase. I think definitely the talent is definitely one of the challenge. So we are working around it as industry come together. The second is even we were talking about the R&D infrastructure. So because a lot of them, they're working on L2 plus, right? So we don't have the at least autonomous infrastructure, which you do the whole R&D, but to do the end-to-end testing, right? So this is the 2 major challenges. Sure, you wanted to add anything?
Kishore want to add, because as a technology company.
No, so absolutely when we are working together, I think there is one part which I think is the skill gap is there in India. I mean, having engineers.
When you say skill gap, any particular areas where you think India needs to
for
catch
many
up?
of this technology, you need a little different level of skills.
Okay.
And all of us are putting a lot of investment in making it happen, and it takes some time. So it is still, I mean, we all have figured out how to manage it to some extent, but the fact is there is a gap.
And which is where, and this is an HRD issue, I mean, in terms of human resources
it's
also,
a
right?
deep technology is required, required. And I think the ER&D part, which we have been talking about again and again and again. So infrastructure and ER&D projects has to be there. You cannot only work on a production projects.
Right.
It is not possible.
I think also classical ER&D in GCCs of India, right? Started off with, I gave you requirements, or I told you work package, you deliver that. You knew how to do this.
Something like the component industry
Yeah,
earlier.
you knew this,
build
yeah,
to
but
print.
now they're not telling you what you want. They're not giving you line by line instruction, this is what I want to develop. The new age customers, they're telling, they're only giving you one line.
The pain
so
point.
am I able to consult them, am I able to drive their specification? So the engagement level is changing completely. It's no more just being technically, do I understand C, C++? I think that's anyway Gen AI will take care in the future. So it's about, am I able to understand the system, the domain, am I able to talk to the converse with the customer at a level where I can actually be a consulting kind of a role, right? So the skill has to completely change the way we think in the future.
And one more point would be it could also be even in the leadership skills. Because when we started off, as Guru mentioned, it is, you were only in one part of the value chain. Now we are talking about India behaving as an innovation hub for your parent company. In that case, even the leadership who is sitting, they should have the global exposure, understanding global requirements and the ability to scale up. And a lot of agility quotient is also required to handle customers. For example, sitting in India, we handle China customers, Japan, Korea, rest of the world, right? So each of them have a different speed of operation, different style of operation, cultural complexity which is involved. So that understanding is also required for the R&D engineers to do. So the skill is not only technological skill, that's one part of it. There's beyond that if we want to be much more successful.
Right. Staying on this subject, Kishore, when it comes to addressing these kind of gaps or challenges in the ER&D industry, policy interventions may also help. And we are here sitting in Bangalore, and I think, if I'm not wrong, Karnataka was the first state to come up with a ER&D policy. So what kind of interventions would the industry expect, and which will benefit at a larger scale India's competence in the global arena?
We talked about it. I think this is where we spend a lot of money. But we need to take it a little beyond, and we have to really understand and go through, because this research and infrastructure is as critical, and we have to find out, because till that time, developing the talent becomes a very tedious process. So that is the one part, and we are working. We are working with the government, central, state, other parts. Now government has also come out with some funds in this area. So we will see how this can be enabled, and that is going to be very important for future. He had some point.
One point which I wanted to say, that typically a learning cycle means if you teach a particular student about new technologies, that knowledge stays for 1 week unless he or she practices it, right? So learning by doing is very important, and that's where I think the Apprenticeship Act of the government, or the internship, or the US or UK model of having longer internship period, where you not only teach but imbibe them in actual real life projects is important. So I think a good combination of curricula, but internship, not 6 months, but 1 year, should be helpful. Then the learning speed of acceleration of the learning is accelerated, So that's where I think most of us are trying to do this, having longer internship period and giving real life projects to the students.
If I can add a couple of statements. I worked in Vietnam and also working closely with China before. The kind of investment they do in the vocational school, which is what he's talking about, it's not about just learning for 1 week, 2 weeks. It runs for 3 years, 4 years. And again, coming from a German industry background, I think Germany started this kind of vocational concept long back. And we do also in India. But I think amount of spread that countries like China, Vietnam does is amazing. So unless we strengthen it, I don't think we can develop our supply chain stronger here. And make people lot more towards the practitioners than being just theoretical.
Great. A lot to discuss, but we have very less time left. Coming about to you, Debashish, Guru mentioned about the China speed. And but first thing that comes to mind is the benchmark that the Chinese have set in terms of vehicle development, which again, globally, the life cycle is shrinking. I believe they've, in 1 or 2 odd cases, they have cracked the sub 1 year period of vehicle development. What's the latest, and is that putting a lot of pressure on tech centers like yours?
Definitely. Things are hotting up in the rest of the world because of China. Typically, I talk on the European context because we're working very closely with European and Japanese companies, Renault and Nissan. Typically, the first intention is to develop car in 2 years. I know the Chinese could do in 18 months. They are claiming that. And I would say there are 3-4 main levers on which we are working. The first lever is how we can onboard the partners, the suppliers, at a very early stage of the development cycle. And then that co-creation with the partners is very important. We don't onboard our partners later. And then we say, you stick to the specification, and then you say, you go through iteration cycle, and then you sort of lengthen the speed of your execution. That is what the Chinese are doing, right? They onboard very fast. Of course, they have mastered standardization to a great level. We have a long way to go in standardization.
And it's an industry level.
Industry level standardization, like literally plug and play. We are not. But at least the least we can do is to onboard suppliers faster. Second is agile way of product development. Just like software development is done in CI/CD concept, continuous integration, continuous development, the mechanical engineering also has to now be agile and go in an agile way. So it is completely new way of car development with agile concepts, squads, zonal concepts, where all the actors are in one place. The partners are there, the product engineer, the process engineer, the purchasing guy, everybody is there. And decisions are taken on the fly to take decisions faster. Then comes digital twin, the power of artificial intelligence and the digitalization. And as much as possible, the intention is to reduce the digital phase, because physical phase you can't do much. You need to have the time taken to set up the plant, etc. But how you can virtualize both product and process through digital twins and artificial intelligence and advanced simulation to shorten it.
I presume you are already putting at least some of that in
Exactly.
place for Renault Nissan.
So I would say the coming products in Renault Nissan will be 2 years.
Okay.
Coming products.
So just to put it in perspective, let's say the CMFA Plus, Dior, Renault, Kiger, and
Yeah.
the Magnite, that took how long?
See, that took around 3 years, I would say. That is the...
But it was all on a modified version of an existing platform.
Yes. So if you say now the future evolution should be much faster, because when I talk 2 years, it is a sort of a platform development,
Ground up.
high level of complexity. But if you talk of derivatives, it should be done in 1 year
Yeah.
or
So
less
you're
than
saying
1 year.
2 years is the next challenge for you? Ground
Yeah.
up. Ground up.
And we are reaching there. I think the future products will be 2 years.
You know, Kishore, talking about this Chinese challenge to the global industry, does India's inherent frugal engineering have an answer in terms of pushing the envelope further and
See, there are
matching that,
two
if not beating
points.
it?
There
Yeah.
are 2 points. I think India for India and what India can do also for globally, like or GCCs, etc. There are 2 things. One is they are in a position to do things quicker. That is one part. And the second thing is their cost. And the cost is very difficult to challenge to certain extent.
Why so?
Because
scale?
the OEM profits, OEM makes about 7-8% profit. The supply chain, tier 1s, etc., not right now, but roughly 8 to 10% they make. Overall, other suppliers, etc. So, and the overall subsidies you get into infrastructure, etc., you take, they have a 20-25% advantage in the cost by itself. And then what they have been in a position to do that through material costs. So that's a advantage is very difficult to kill. But in my view, technology can reduce the cycle time. As he mentioned, 2 years. We already have the many of these technologies which can reduce. You start from the architecture and reduce the overall cycle time very quickly, reasonably, and that can help in competing with that.
And carrying on the conversation, talking about GCCs, Lata, as I understand, India's has a inherent strength traditionally in frugal engineering, but automotive electronics, for example, wasn't a core kind of an expertise, which GCCs, setting up of GCCs has helped by either by, let's say, an MBRDI or a Conti or a Bosch. So any other such areas where Indian engineering has got a fillip with the setting up of GCC, and now really kind of giving it back in terms of contributing through, again, leveraging its inherent frugal engineering and thereby adding more value?
I would say a couple of points. So one is with respect to the innovation to the India market itself, because we all established center here not only for cost advantage, but also to tap the local market. So we have developed certain products for India market, which is much more affordable. And we developed it for India market. Now we are taking it to ASEAN and beyond. So the capability of an Indian GCC to develop a product is gone beyond the border of India, which probably started as a small innovation project a couple of years. So we have multiple products like that. The second point is the virtualization part, the digital twin, plus the COVID advantage that everything could work virtual. All that put together, the talent from India is able to solve challenges globally. And earlier also probably it would have been possible, but there was a lot of mindset issue that, India cannot work with this geography or this particular technology. We need a testing infrastructure. There used to be a lot of bottlenecks to give projects and product work to India. So that is also changing now, because we are able to do a lot of things through virtualization. For example, using digital twins, SDV, the road to cloud in 1 day, 2 days. I think design, prototyping, testing, validation, everything which was done on site on the physical vehicle, we are able to do now. So I think India is, it's a very nice period for India that all these technologies, it's all the software related technologies which are coming in. It is putting us in a very good position to deliver a lot of global projects, products from India. And that I think would continue as an advantage for India in the future.
And when you say that, what was also coming to our mind is also the example of Bosch. The fact that you kind of reposition itself from RBEI to BGSW, and also now being the global headquarter and setting up on subsidiary in Vietnam or
Vietnam, Mexico, Poland.
Yeah. So it's kind of a reverse thing happening, I mean, as compared to the earlier thing of having the global headquarters in Germany. So tell us in terms of the competence, where India is really kind of, your Indian team is really kind of, contributing to global projects and really leading in some of the parameters.
Yeah. I think last time, before I said, it's about how these regional demands are changing. So the speed at which we need to deliver and realize some of the features, which is very local, cannot be visualized or even imagined sitting in headquarters. So now that is what we are trying to enable, being close to the customer. So when we decided why we want to go to Vietnam was because we wanted to get close to Japan and Korea and China, of course. India, of course, we're trying to do it not just for Indian market, but also global market. When we went to Mexico, we said we go into the North American side. So we wanted to get close to the customer so that we understand the both near-shore expectation, local expectation, so that the turnaround time for anything that we are delivering is much quicker and also more relevant to what the local demands are. That's one. Second, I think when you have this diverse talent coming from each region, it also kind of leverages and makes us itself getting even better. Because diversity is always a benefit. And people come with a very different value system and different level of technology, and we are able to challenge each other in even, how can we even do faster than what we did. So when we did with Vietnam, I think we have been now 10 years, their main strength has been their mindset towards automation. Yeah, they're so natural in questioning every manual effort and automating it, which was something I think we learned it later. So that is something we are learning from them. So it's not like we are teaching them. Yeah, it's of course we support them to grow, but we are also looking at how do we learn from each other. So that way, as a global center, we're really trying to leverage to get the maximum benefit for Bosch.
Okay. Since we are also talking about innovations and some of it applicable to outside of automotive sector also, but primarily sticking to, let's say, in the context of today's discussion on electric vehicles, Kishore, KPIT has demonstrated the sodium-ion battery technology, and you say that it's reached a stage where it's ready for industrialization. Very briefly, can you throw some light on what's the status now, and in terms of the gaps that were there compared to other battery chemistry, primarily energy density and charging cycle and all that, how close have you reached, and what is the level of, let's say, what's the status of its industrialization?
Sure. See, I think many of these things, the biggest issue is the business model. You get more time to figure out how the business model or the ecosystem will work. Fortunately, we have figured it out, but it will take, you'll hear something in next 2 to 3 months, something on this. I cannot talk too much, but I may say that we have gone towards actually creating pouches at a reasonable level, and we have tested that. So now basically what we will look for is a manufacturing partner who will be ready to invest and take that, and basically will license the technology.
So it will be a licensing agreement kind of thing. And staying with that, I mean, KPIT was also the first one to showcase indigenously developed hydrogen fuel cell vehicle.
Yeah.
That's another project which is progressing.
Yeah, still we talked about it, cost of hydrogen, and then there are a few other things. But we are making progress. As you know that for this Cochin shipyard, we provided, which Prime Minister inaugurated that those ships were powered by KPIT solution. So at least their boats are there. So,
So the
that's
demonstration level has been cracked,
that has,
now
that
the
has been
business case.
cracked, but now you have to see feasibility and the deployment on a larger scale, which is by itself a different challenge. But we are working on that, and again, we'll require part. We are not manufacturers. We are not as good as Bosch, Conti. So we have to find out the way to really get there.
And sticking to electric vehicles, now what we also see that there are some kind of relooking at the EV strategy of roadmap by OEMs and some other stakeholders also. I'm just to cite a few examples. Mercedes-Benz, which had gone on record saying that 2025 onwards, only EV platform. They've kind of not really, some may also argue that it's a U-turn, now they're relooking at it. Ford has shelved its plan of having a three-row ACV full electric in favor of hybrid. Is this kind of a blip, or do you think perhaps there's a relook in the industry globally of, yes, electric will be the future, but it will not be the only future?
See, we have been talking about, there will not be only one technology which will dominate. There will be all the multiple technology. I think you mentioned that there will multiple application, multiple things. There will be multiple technologies will be done. The key point about EV right now is the reduction of the cost, which has to some extent happened because of the battery cost have come down drastically. But still, if the total cost of the system and this can go down, and with many places incentives have also gone back. So if they are in a position to catch up with that, I think I personally don't think that it's a blip. It's not a reversal of a trend for sure.
Okay. Lastly, since we are talking about R&D and innovation technology, India's status and kind of near to long-term growth path in the ER&D space. Just quick, brief comments from each one of you, starting with you, Shiva.
Yeah. So as I said, right. So we were at $44 billion in terms of the revenue or exports. Sorry, and we are aiming for about 150 to 170 billion dollars by 2030. So that's the aspirational target for the industry.
Kishore, in terms of the technology capabilities and in this
I think, these targets we may meet, but I think we have to do a lot in terms of talent, research, infrastructure. I think that is very, very critical, and changing of that mindset, as she mentioned about the leaders, innovation, putting it together. While we are doing it, all of us are doing it for sure. But I am seeing whether something, the greatest can come out of India. It will take some time. If we can go on this path, we will.
I say that the golden era is yet to come. Yeah, we are on the good path. The biggest asset what we have is the talent. The government has been pretty stable now, and there are a lot of policies which are also helping. So I think we are in the right path. The second advantage is that now if you look at all the technologies what we have, it is all domain agnostic. Whether it's an AI or an IoT or a cloud or whatever it is, whether it's manufacturing or whether it's healthcare or automotive or wherever, it's a kind of a domain agnostic. So we are able to actually get this particular technology, the cream of this technology, and develop talent in that. I think that will be a big game changer for India.
For me, I think the standard skills will be disrupted. If standard skills gave us the growth that we had in the last few years, that I think we should forget it. Because Gen A will come in and will kill all the standard skills. We don't need it. Maybe a few more years, but afterwards we don't need it. So we need to change. Our skill has to be upgraded. And our value creation has to be different. It can't be a low cost as a location. That is what is going to play us. I think we need to play more of a global capability centers. We need to bring this innovation. We need to talk, empower more on the regional strengths. Because if really India is going to grow the way China would grow, so there is a huge market for us to contribute.
That's the point, actually.
Yeah. So I think there is so much more. I think I would say we can look forward, and we have a big role to play. And also again, GCCs, like Lata before mentioned, we are actually working together with entirely across global. We know how to operate with Japan, China, Korea, Europe, US. So how can we use this east to west knowledge that we have to build ourselves into even more stronger to be the emerging market solution provider? I think there's a role to play, so we can take even more stronger leadership role in this way.
Right. So as you said, perhaps we need to kind of take a relook at what our strengths today are and realign, keeping in mind the needs of the future. So thank you very much, everyone, for spending your time.
Thank you.
And
Thank you.
indeed, very, very enriching discussion. Yes, India has reached a certain stage, but just to borrow the words mentioned by Lata, the golden era is yet to come. And then we heard what needs to be done to reap the benefits that are there for India to tap and really emerge as an even stronger technology and engineering hub for the global industry. On that note, thank you for watching this episode of Technology Talks. Take care and goodbye.